Section 2 of Chapter 5 is talking about trigonometric functions. So if we start with our angle in standard position, okay, so like this. So you have this angle here, and say there's a point on this angle out here, and this point out here has some x value and some y value, right? And then so that y value would represent the height, right? And the x value would represent here the width. And then we have our, as you can see, what does it look like? It kind of looks like a right triangle. So we have this right triangle where we have the x and a y, and there's this famous theorem about finding the distance from this point to the origin. Now for now, we're going to call that distance r, and that will come into effect really when we actually look at chapter 6. But how do we find r given some x and y? Well, that's Pythagorean theorem, right? A squared plus b squared equals c squared. Get rid of that squared by square rooting both sides. Now remember, when I square root this x squared plus y squared, it doesn't equal x plus y, right? Alright, I can't cancel. That's not the square root of x squared plus square root of y squared. That's not true. Okay? So that's how we find y. Well, this is useful when we look at the relationship between the two sides. You know, how does x relate to y? How does y relate to r? How does r relate to x? And we look at these relationships between the three sides of this right triangle. And we do have this angle that we're referencing here that opens up here, this angle theta. And so we talk about this angle, and we can always create right triangles off of anyone. So even if I open this in the third quadrant right here, so this angle looks like this, I can create, say, some point here, I can create a right triangle. If it opens up in the fourth quadrant, say right here, I can create some triangle related to some point on that ray. And it will have the same relationship, right? You'll have your x, your y, and your r. And you find your r by taking x squared and y squared, adding them together, and then square rooting that answer. And remember, r is always going to be positive because it's the distance, right? Well, what comes from that and that relationship between the three sides are these called trig functions, or trigonometric functions. And that describes the relationship between the three sides. Well, here they are. Sine of theta. Also, note, this is how you write it. This is how you say it's sine, but that's what's called sine, S-I-N-E. And its a relationship. It describes sine of some angle. This is just an angle, right? Is the relationship between your height and the hypotenuse. Okay, your y over r. COS is cosine, and that describes the relationship between x and r. And then TAN is tangent. Okay, that describes the relationship between y and x. This bottom one it's going to sound confusing, even though it starts with a C. It goes with cosecant. Secant. And that actually goes with sine. So these two actually go together. Okay, and then secant goes with cosine. So I remember when I say secant, there's a C. It sounds like C, and that goes with cosine. And then there's cotangent, and that goes with tangent. And you notice that the difference between these two is just I flipped my fraction here. I flipped the fraction here. I flipped the fraction here. What do we call it when we just flip the fraction? Well, that means reciprocal, right? So these are reciprocal. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. Sine and cosecant are reciprocals, and then tangent and cotangent. So sine, cosecant, cosine, secant, tangent, cotangent. Those are reciprocals of one another. So let's go ahead and look at some examples and see how we can do this. So if we're finding trig functions of an angle in standard position by passing through the point 815. Find the six trig functions. So we have standard position, and it goes to the point. Here's our initial side, and our terminal side is going to go through this point 815. So say here's this point 815, and our terminal side is going to go through that point. Ooh, missed it. It's going to go through that point, right? At point 815. So we have some angle, and we want to find sine of this angle, and you can label this anything, angle, anything. I'm going to label it theta. And so sine of theta is my y over my r. Well, I have my y right here, and this is my x, so my x is 8, and my y is 15, but I don't know my r. So if I take my x and I square it, and I take my y and I square it, and I add those together, so 64 plus 225, so 289, and I square root that 289, I get 17. So r is 17. Okay, so now I can do these ratios, right, between the sides, the relationship between the sides. So sine of my angle is y over r, so that's 15 over 17. Cosine of the same angle is x over r, so that would be x over r, which is 8 over 17. And then tangent, which is y over x, so tangent would be my y, which is 15, over my x, which is 8. So those are what they are. Now we can do the reciprocals. So reciprocals just mean we flip them, right? So cosecant, the reciprocal of sine, is 17 over 15. Secant, c, cosine, flip cosine, so that's 17 over 8. And then cotangent, the reciprocal of tangent, so we flip 15 over 8, and it becomes 8 over 15. So those are the 6 trig functions. Now, the same thing is happening, right? Even if I give you a different one. So even if I give you a different problem, all it's about is finding that x value, that y value, that r value. Okay, and I think I'll do another one right here or in your homework. Right. So here's another one. So standard position, we end at negative 3, 4. So go ahead and graph that point. Negative 3 up 4. Okay. And now go ahead and draw your triangle. Right, you can draw your position first. So we're looking at this angle that goes from here to here. Okay, so theta, a, what it be, whatever. And we just need our x, which is negative 3. Our y, which is 4. You can draw a triangle, you don't need to. And our r is just squaring those. So negative 3 squared plus 4 squared. And then square rooting it. So 9 plus 16 square rooted is square root of 25, which equals 5. So r is equal to 5. So now we can do sine is y over r. So 4 sine of our angle, right? Don't forget to put your angle symbol in there. So 4 over 5. Cosine of our angle is negative 3 over 5. And then tangent of our angle is y over r. And then we can do the reciprocals, right? Which means just you flip the fractions. So the reciprocal of sine is cosecant. So maybe that one secant, so it can't be cosine. So you say c, so c makes you think cosine, but then it says can't, so it can't be cosine. Maybe that's a way to remember it. I just thought of that now. Wow, amazing, isn't it? So that's 5 over 4. And secant. Oh, maybe that confused you. As I start to think about it now, so negative 5/3. and then tangent. Or sorry, we already did tangent. Reciprocal of is cotangent, and negative 3/4. So think of a way that you can remember cosecant. And remember secant. Maybe, I don't know, maybe can't be secant, or can't be cosine. Two C's can't be cosine, I don't know. Something. Help yourself out here. Figure out something, a way to remember that. Okay, here's another one. So we need an x and y, right? So we have some standard position. We have this angle opening up. Right, here's our terminal side. Our ending side, right, our terminal side is actually defined by this equation. And then our x's has to be greater than 0. So, well, what you can do is just pick an x greater than 0, say 1, plug it into your equation here, and solve for y. Or we could graph this equation, right? We could put it in slope-intercept form, y equals -1/2 x, right? Or you could plug in 0, right? That's the easiest way to do standard form. Plug in a 0 for x. What do you get for y? Right, you get 0, so you get this 0.00. Plug in 0 for y. What do you get for an x? You get 0, 0. So you can't find a second point there. But you could use the slope, right? Down 1 over 2. Down 1 over 2. So I actually have several points. I could keep on going, right? So I could use this point to -1. I could use this point for -2. Any of these two would work for my x or y. So then I just have to find my r. So if we do our x is 2 and our y is -1, that means my r would have to be squaring those, adding them together. So 4 plus 1 is 5. And then square root that, so we get square root of 5. Leave it as square root 5. Okay, so sine of our angle is y over r. Now I can't leave that radical on bottom, so I have to rationalize it. So I'm going to multiply top and bottom by root 5. So that means sine of our angle is equal to actually -√5 over 5, because 5 times 5 is 25, and the square root of 25 is 5. Now, cosine, that is x over r. Rationalize that, right? So that's going to be 2√5 over 5. Okay. And then tangent, that is y over x, so -1/2. Then we can do the reciprocals. Cosecant goes with sine, so that is -√5. Secant goes with cosine, so that is √5 over 2. And cotangent goes with -2. Okay, so those are all 6 of there for you. So those are some few different types that you can practice. And so when we look at any equation and we start to see if we have a linear equation that defines that terminal side, well, you can recall that when we look at the equation in slope-intercept form, y equals mx plus b, that coefficient m is our slope, right? So m is our slope. So that's our slope. And we notice that it turned into y equals -1/2 x, right? If we would move our x to the other side, right, -x, so we get 2y equals -x divided by 2, so that's y equals -1/2 x, right? So you notice that our slope is -1/2. Well, what did you notice tangent was? Tangent was also -1/2. Well, actually, in general, it comes to find out that tangent of our angle is actually equal to our slope. So just make sure, if you're using a calculator, make sure to approximate these values to get them close, that you are rounding, right? So if you are round, that's not an exact number anymore. Okay, so make sure if it wants an exact answer that you leave it as a fraction or you leave it as a root, okay, rather than use a calculator. Alright, let's go ahead and do some example problems. Okay, so on page 496 we can look at number 5, number 7, and number 35. So if we take a look at these, and go ahead and start working through these. So let's take a look at number 5 first. So number 5 is kind of like our first example, negative 815. So that's the point that it's going through, right? So you can go ahead and try that out. Because really, in our example, we were right here, right? At positive 815. Well, negative 815 is just on the other side, so isn't it? Our r should be the same, right? Our r should be the same there. So we have negative 8, positive 15. Square those, we get 64, right? Square that 225. Notice that's 289. Oops, 89. And then square root that, and that's 17, right? So there's our r, so we have our x. We have our y. And we have our r now is 17. And then we can go ahead and find these trig functions. Is y over r, so 15 over 17. Cosine is negative 8 over 17. Tangent of our angle is 15 over negative 8. Try to combine those. 15 over negative 8. And then the reciprocals, so cosecant of sine, 17 over 15. Secant of our angle, don't forget your angle in there, is 17 over negative 8. And then cotangent of our angle is negative 8 over 15. Okay, so there's number 5. We can go ahead and look at number 7 now. Switch up the colors here. So number 7 is 7 negative 24. Number 7. So same kind of thing. We gotta square those, right? So 49, 24 squared. That's a bigger number. 576, I believe. So I'll check that out. Okay, yeah, 576 and 49. Add those together. We get 625. Square root that. That's 25. So we have our x. We have our y. Negative 24. And we have our r is 25. So sine of theta is equal to our y over our r. Cosine is our x over our r. Tangent is our y over our x. Reciprocals, cosecant. It's flipping sine. Secant, sec. It's flipping our cosine. And tangent. Oh, I already did tangent. How about cotangent? Is 7 over negative 24. So you notice that some of these have positive and negatives, right? So some of them has positives and negatives, and we'll actually just look at what quadrant our angle's in a little bit later and figure out if our answer is going to be positive or negative based on what quadrant we're in. So that'll be the next section. But let's go ahead and finish this with number 35. So number 35 is given this equation. 2x plus y is equal to 0, but this time, well, actually, isn't that the one that I... Oh, nope, it's not the one that I did. Okay, and x is greater than or equal to 0. Right, so that means that basically we're going to be in the first quadrant, right? Or actually, no, we're not. We're going to be in the fourth quadrant again. Because we got it, if we put this in slope-intercept form. So y equals negative 2x. So we have negative 2. So we go from 0, 0, right? Because we don't add anything here. So our slope, our y-intercept is 0. Then we go down 2 over 1. Because we rise first and then we run. So we have that point 1, negative 2. Right? And then so we could use that, or we could find more. But we're just looking at positive x, and that is a positive x. So we're looking at this angle here. Either this angle down from there, or this one that wraps around there. It doesn't matter. It ends at the same spot, right? They're coterminals. So our x is 1, our y is negative 2, and our r is 1 squared plus negative 2 squared, which is 3, or 5, sorry, square root of 5. Right, so we get the square root of 5. And now we can find sine of our angle. And notice that tangent of our theta should be negative 2, because that's our slope, right? So let's find sine of theta first. That is y over r. Rationalize that denominator. Right, so negative 2 root 5 over 5 is our sine of theta. Now we can switch our x. So to find cosine is 1 over square root of 5. Rationalize that. So cosine of theta is equal to root 5 over 5. And then tangent of theta is our y over x, which is negative 2. So we were right. Now we can do the reciprocals. We have cosecant of theta is root 5 over negative 2. We have secant, which goes with cosine. So we'll flip that fraction, we get root 5. And then cotangent is negative 1/2. See? So there you go, there's all the examples for those.